Hi and good day from Team Orange. In this video, it consists of 4 main contents, which are the division of the workload and the participation of each member in the subsystems. The second one, the summary on the activities that has been completed according to our timeline. Next, the highlight of the contribution of all 4 subsystems. And the last one is the description on the final results of our RC plane. Here are the 2 illustrated pictures of our RC plane named the Baymax.
This is our team members, which consists of 8 students, which are Hidayah, Husaidi, Hanif, me, Ainul, Shada, Sivashankar, Mariwon, and also Randy. And this is our team leader, which is Hidayah. Job description. We have 4 roles that need to be fulfilled by each member. Firstly, we have the coordinator. It needs to remind the team's member of when and where they should meet, and also keep everyone on task during team meetings. And it has been fulfilled by Hidayah and also Randy. Secondly, we have the recorder. It needs to assemble the product problems and also its solution. Record all the product components used to fabricate the RC plane. This role has been fulfilled by me, Ainul, and also Mariwon. Thirdly, we have the checker. Checker, it double checks the final product, making sure it is complete, error-free, and turn it on time. And it has been fulfilled by Shada and also Hanif. Lastly, we have the monitor. They make sure every team member understands every part of the final product, explain everything with it in teams of 3, and any other team members may also assume the duties as the monitor, but here the main monitor is Husaini and also Sivashankar.
The 4 subsystems involved are material and structure, the aerodynamics, the power and propulsion, and the control system. Each subsystem has their own role, where the first one in material and structure, they involves in material selection and conduct the structural test. Second, aerodynamics, it involves in aircraft sizing and stability, while power and propulsion, where the subsystems perform tests and calculation upon which batteries and motors selected. And the last one, the control systems, working on the coding for flight control and preparing the schematic diagram for the whole control system of the RC plane.
The objective of our design project is to build a Pilates RC plane and fulfill the required mission. The first mission is to be able to fly with a steady flight and complete the course layout as can be seen in the picture. Mission 2 is to be able to carry a load of 1 kg solid state.
With the reference to the lightweight aircraft Pilatus PC-12, the design of the RC plane has been developed with some changes made to the plane. The changes are in the type of appanage from T-tail to the convention tail. Also, the wing was changed from trapezoidal to rectangular, and the initial parameters of the weight of payload, shape of the wing, type of empennage, wingspan, and also the airfoil configurations. On the second picture, you can see the final conceptual design for our project, which covers the design has been changed, thus that the performance would be better and enhanced for our project. Thank you.
For the project summary, we have 5 phases. First phase is the project conceptual and intentional, which is the planning for the project and the proposal preparation. For phase 2 is the project definition and planning, which is the conceptual design, preliminary design, budget, detail design, and the part parentheses. For phase 3 is the project launch of execution, which is the prototype development, mechanical, structure and programming, electronic installation, and final assembly. For phase 4, we plan to do the project performance and control, which is the flight test, functional test, effort and cost tracking, and performance check and final touch-up. But unfortunately, we were not able to do that, to do the flight test because of MCO, so we stopped in the fabrication process. For phase 5 is the project close, which is the project demonstration and the report.
So this is the final decision of the aircraft configuration that we have been selected. So the first one is we use 4412 for the wing, we use NACA 0006 for the elevator, we use NACA 0001 for the fin. The reason why we choose that because we have done multiple analysis via XFLR5 software to analyze the generation of the lift and also the induced drag that will be produced by our aircraft. From that analysis, we can simply conclude that our aircraft will produce more lift than to produce drag. So this will give our aircraft more thrust and also to minimize drag as small as we want. As you can see the figure below, we have been conclude that the aircraft configuration that we have choose with the result from the analysis that we have done so far. For the next presentation, we will give to Randy.
Right, thank you Hanif for after explain why we're using NACA 4412 for our aircraft. And here's the main wing design and the detail shape design. So for the main wing design is attached below of the structure fuselage, and we're using a direct angle design. One of the reasons is to improve the performance of aircraft to return the original climb wheel level wind condition. Also to produce the negative rolling moment to stable the aircraft while there's a bad condition of that, and we have done some analysis and we get the efficiency up to 0.713. And for the detail, we have some consideration and based our reference shape, which is Pilatus plane, and our team decided to use the unbalanced cross-section shape. The reason is to provide the stability during flight and directional control. So one of the advantage is to get less the loss of while we are flying there. And that's all for the adrenaline part. And thank you.
For the propulsion system, we will use as per state component that mentioned in the figure. Roughly, this is a figure that include with the information that we need to identify before we develop our propulsion system, such as the weight, motor type, kV, number of cells, and propeller blade diameter. So actually, we should referring to the Pilatus airplane, but due to certain reason, for example, the amount of thrust that produced at current scale, and also in terms of fabrication, we took consideration to decrease the amount of propeller. Thus, we made a comparison and we identified that two blade propeller produce 2 pressure pulse per revolution, whereas a 3 blade propeller will produce 3 smaller pulse per revolution. For the same amount of total thrust, in general, the 3 blade propeller will have a smaller diameter than the 2 blade propeller. This will help to reduce the scale of the blade itself. After using some engineering tools, for example the ECAL, to aid our data finding, aside from calculation, we found out that our scale, when using 3 or 4 propeller blade, it doesn't achieve the desired pitch. The pitch speed should be at least twice as large as the estimated stall speed. The propeller will still develop some thrust at this speed established chamber, but not much. ECAL will predict great static thrust with a large diameter for low pitch with a low RPM propeller. But if the dynamic thrust drop off too fast, the model may be partially unflyable. So we proceed with the 2 blade propellers. As for battery selection, we use Omni calculator as a tool to find our desired battery and the flight time that we want to ensure that it meets up the flight time requirement to complete the mission before the battery run out, and also we want to ensure that we didn't over exceed the spec because of costing and also performance of the aircraft. So after obtaining the data, we transfer into a drawing to develop fabricate, and we use the finalized dimension for us to design the propeller blade and battery itself to mount on the airplane. So After obtaining all the data, we will double check with the ANSYS software to ensure that our design will be no problem, and if there is, we will use a early counter to fix it to reduce all the cost and other element. So that's all for the propulsion system. Thank you.
So as for the control system, we're gonna focus on the electronic parts that have been used in our RC plane. We have been used a transmitter, receiver, 4 servo, battery, push rod linkage, electronic motor, electronic speed controller, and also a wires. So as you can see in the drawing package below is the location of some of the electronic parts that have been used in our RC plane. So there is 4 servo that it has been connected by the wire that will be control the aileron, the rudder, and also the elevator. And as you can see at the gray box is representing the battery and also the electronic speed controller, and we also have the motor right after the propeller.
Hello, my name is Mariwan Sultan Elias John. So this is materials and structures. So the materials consist of dipron foam, aluminum wires, some of balsa woods. There's actually another balsa woods, which is the long one, and tires, the servos for the flaps, and waterproof transparent tape. So this waterproof transparent tape is very strong and it's waterproof, so it's good for the fabrication stuff. So and then this is the structure. So on the right side is what we have designed, and on the left side is what we have fabricated. So what we have designed is, as you can see, the body is a little curvy, and if you compare it to the fabricated one, which is on the left, it's boxy. It's not little boxy, but it's boxy kind of planes lah. If you and parameters wise, all the wingspan, the length of the fuselage, the radius of the fuselage, the length of the stabilizers, the vertical and horizontal stabilizers, all are the same. All are kept at what we have designed in the first place. I think that's it for materials and structure. Thank you.
So move on to the next part. We will be talking about the fabrication process. As you can see in this slide, we fabricate the wing, the empennage, as well as the tail, which is fin, and also the elevator, and also we fabricate the fuselage. And then after that we install servo so that we can create control surface for our design aircraft. So in this part, I will be talking about the final design after the fabrication process that has been done by us throughout this semester. So this is the combination or the assembly of the wing, tail, fuselage into one unit of the aircraft. So this is the combination of all subsystems into one to form a complete aircraft. But is it hard to say that we are unable to complete all the assembly of all the units, including control system part? However, we already installed the servo for all parts of control surfaces, but we can manage to install propulsion system to our design aircraft. So it will consume a lot of time since we are now in MCO period. So that's it from me. To sum up for the conclusion for our aircraft design,